Hello all, welcome to this lecture on elements of mechanical engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering from the College Institute of Aeronautical Engineering. In this lecture, we are going to study the applications of robots in material handling and processing. We are in the fifth module of this course called Elements of Mechanical Engineering, where we are studying the automation systems. In these automation systems, there are two types. First kind is related to CNC machines, where we will automate the general machines which are used in manufacturing industry, like lathe machine, drilling machine, etc. And second kind of automation we are studying is use of robotics in manufacturing industries. We can use robots in many purposes, like doing some complex operations like manufacturing processes and doing some material handling operations where the robots are used for moving the objects from one place to another place. So in this lecture, we are going to see how the robots are used in material handling and processing operations. We'll see what are the general applications of robots. So back in the year 1960s, where the Unimation was first formed and the first industrial robots were developed. Unimation is the society for companies which manufacture robots. So in 1961, the first industrial robot was invented and it was came into existence. Then it was used for removing the casted objects from the die cast. We know the process of casting. Casting process is where we will convert the molten metal, and this molten metal is poured into a mold cavity where it gets solidified and it is converted into a solid form which of the required shape. So during the casting process, what happens is the molten metal, it emits some kind of gases or fumes which are very dangerous for human beings. So that is why while removing the hot object from the mold cavity during casting, we need some other machine which can do the work automatically. Instead of a human being, we need a robot. So the robots are used then for removing the hot metal object from the casting equipment because it is of high temperature and it also emits some kind of dangerous gases which are very harmful for human beings. So these robots are used for unloading the castings from the die casting machine. The heat and fumes from the casting are very dangerous for human beings. So that is why robots can work in this place safely. Only the thing is, the robot should be able to handle the high temperature that is coming out of this casting process. And then let us see some applications of robot where they can be easily used. Hazardous work environments. When the surrounding environments in an industry or a manufacturing unit are very dangerous and hazardous for human health, then we can use robots. When the environment is unsafe, unhealthy, hazardous, uncomfortable, and otherwise unpleasant for human beings, their robots can be applied, where they can be used for doing the particular task. Now they can be used for some applications like spray painting, continuous arc welding, spot welding. You can see in this picture, there is a man who is working in the environment of a lot of chemicals. In this place, it is very dangerous for human beings when some of the chemical, maybe it is an acid, it may fall on his skin or the fumes coming out of this chemical may be when exhaled or inhaled, they could be very dangerous for human lungs. So that is why we have to wear a very large equipment, like he is wearing a suit and he is wearing some kind of protection for nose, protection for eyes. So there is a lot of protection he has to wear while he has to work in this kind of environment. When working in this kind of suit for longer hours, it is very uncomfortable for a human being because it may cause very heat inside the suit and he may not breathe easily through the mask and all. He may not see clearly through those goggles. So that is why In this kind of situations, we can use robots for relieving the human beings from such a hazardous environment. So some applications of robots where they can be used in manufacturing industries are like they can be used for spraying the car bodies or any objects. Mostly in automobile industry, they can be used for spraying the car bodies, painting, and they can be used for welding the car bodies, and they can be used for doing spot weldings also. Now we'll see in detail what are these operations and how the robots can be used to do this particular operation. And second kind of application is repetitive work cycles. In this picture, we can see a robot is working on a similar items, like 10 to 12 items are there. They are being manufactured and they have the same dimensions and shape. The robot has to do some kind of operation on all these objects repeatedly. I have to do a cycle of operations, like I have two set of operations, like operation 1 and operation 2. I have to do these two operations on every object here. Now, doing these operations, if a human being is placed in this for doing this work, he may get boring because he may get tired easily because the work is very repetitive. That is why he has to do the same work on each and every object. Another disadvantage of a human being is that we can work precisely for only a shorter period of time, and after that we may lose our precision because here we have to do the same kind of operations on all objects. When we are working on multiple objects throughout the day, like 8 hours a day, the works will be very tiring and human beings will lose their precision while working for longer hours. So that is why robots are used where repetitive work cycles are there. If the sequence of elements in the cycle is same and consistent of relatively simple motions, then we can use robots. A robot is usually capable of performing the work cycle with greater consistency and repeatability than a human worker. So when we want repeatability, even though in repeatability, if we want precision and more repeatability and great consistency if we need, then we have to go for robots in any industry. I mean, we are discussing about industry which is related to manufacturing units. So that is why the robots should be used to automate this process. Next thing is the tasks which are difficult for human beings. They also can be done with the help of robots. Like in this picture, we can see there is an object which is being handled by a robot. This object is very heavy, like 30 to 40 kilograms of weight it is there. If a human being has to lift this object from one place to another place while doing some operations, it is very hard for human beings because this is not the only object he will be working on the entire day. He has to work multiple objects of similar kind throughout the day. So that is why if we want to lift this like 100 objects like this, each object carries 30 to 40 kilograms of weight. If he has to do this lifting operation throughout the day continuously, he may be very tired and he cannot do that work with efficiency because human body is prone to tiredness and they will lose energy instantly. So that is why we are installing robots for doing the heavy tasks like lifting the bodies, lifting objects which are very heavy when compared to a human being. So if the task involves the handling of parts or tools that are heavy or otherwise difficult to manipulate, it is likely that an industrial robot can be used. So we know that an industrial robot is a very strong, sturdy robotic arm which contains a lot of actuators made up of pneumatic or electric motors. So they can carry a large amount of weights. Mostly for lifting weights, we will use hydraulic actuators where they will give more precise movement when compared to pneumatic. When the load is very high, we should go for hydraulic, not pneumatic. And sometimes we will use the electric motors, DC motors, etc. While if we want to manipulate the object while shifting from one place to another place. Now see, this robot has to move the object from point A to point B. While moving the object from point A to point B, the robot can manipulate or rotate the object in such a way as required by the next cycle of operations. So this manipulation also can be done easily with the help of a robot. So whenever the parts are tools that are heavy for human beings, then these objects can be conveniently lifted with within the capacity of the robot. So every robot will have a fixed capacity of load which it can lift or carry. So within that limit, the robot can easily lift the loads and move the loads from one place to another place. Even the robots can be attached with a special equipment where they can work while moving the object from one place to another place, like grippers, magnetic gripper, uh, vacuum gripper. This kind of grippers also can be used to lift the objects. When the objects are very heavy, we should always go for hooks, where a hook will be attached to the robotic end effector. Then it can be used to lift the object from one place to another place. So this is another application which are very difficult for human beings. Now this is multi-shift operations. When I want to use a robot, I can use it for continuously 24 hours a day without losing any time. Whereas human beings, if I want to make humans work for a particular task, we can make them work only for 8 hours. More than 8 hours, the efficiency will be reduced, and it is against the laws which are made by the committees and governments. So, in manual operations requiring second and third shifts, substitution of a robot will provide a much faster financial payback than a single shift operation. If I want to use a skilled person, he can do the particular operation only for 8 hours a day, and the remaining 16 hours are wasted, or I have to take another 2 persons to do this work in the remaining 2 shifts. Now, instead of using 3 persons, or I can simply install a robot and I can use the robots for doing particular operation. A single robot can work for entire 24 hours a day, and it does not get tired unless it got some repairs and malfunctioning, and it does not need any leaves when compared to human beings. It can work round the clock. So instead of replacing one worker, the robot replaces 3 workers, 2 or 3 workers in a day. So in this picture, we can see this is a depiction of how robots can be used for doing operations, like when they are working in a packaging company. Like this is depiction. This is no an actual image where the robots are used. This is completely depiction. So we can use the robots, like these are humanoid robots. These are not so advanced in the present scenario. They are advanced in such a way where they can speak, talk, and they can walk. They can act like human, but they cannot actually work like human beings. If we want to do this particular operation like packaging or moving the objects, we can use industrial robots, not humanoid robots. So this is another application of robots where they can be used for doing multi shifts. Like they can be used to do work for 8 hours in each shift, and they can work for 3 shifts a day. And then infrequent changeovers. This is very important concept when we are studying the robotic applications. Here, what happens? Most of the machines, most of the automation machines or normal machines, they require changeover. Changeover itself indicates the removing or the repair or maintenance of the parts inside the machine. So most of the operations require a changeover of the physical workplace between one job and the next. And one more thing, a changeover of the physical workplace is that we have to change the workplace environment around the robot or any automation system. Okay. So when we are using a robot, we can require very small amount of changeovers. We don't need to change the work environment or the working capability of the robot each and every time. We can set a number of operations that can be done by a robot in the program, and this can be used for doing multiple operations one after the other without losing any time. So if I want to use the robot for a particular purpose, like loading an object into the lathe machine and unloading the object from the lathe machine. So this is one set of operation where I can use this robot simultaneously for another machine like drilling machine, where I can use the robot for drilling operation. So the same robot can be used to do the operations on lathe machine, as well as I can use the robot for drilling also. I can attach a tool to the robot, and this can be used to drill holes into the metal plates. So the two operations, generally the two operations require a lot of changeover. If I want to use the same machine, if I have two different machines, there is no problem. If I want to use the same robot, I have to change the tools. So, but this changeover is very less when compared to other automated machines like CNC machines, where we can connect it multiple tools or handling grippers to the robot, and we can use it for multiple applications one after the other. So this changeover time is changing the objects or the tools which are attached to the robot in order to make it usable for another set of applications, like when one set of operations is completed. Now this changeover time is very less. We can easily attach the tools, or we can easily attach the grippers to the robot, and we can change the robotic program very easily when compared to other automation systems like CNC machines. Now this changeover time is very less when compared to other machines. The time required to make the changeover is non-productive. It does not produce any objects in the industry. So that is why this has to be reduced as possible. And in an industrial robot, the production is relatively long runs where changeovers are infrequent. When we are using robots in the industry where there are no changeovers at all for a particular time, or they may require very small changeover time, then we can get maximum possible outcome from the robots. That means they can work for more hours, they can produce more products, and eventually the industry will get more profits than using a other automated systems. So this is one advantage or application of robots, where they can be used for very infrequent changeovers. And then we'll see what is a material handling application. Material handling applications are those in which robots move materials or parts from one place to another place. As we see, there are two kinds of applications that can be done by any robot. So far we have seen what are the different processing operations that can be done with the help of a robot, like welding, painting, etc. So these are the applications where we can use robots for different processes like welding, painting. And coming to this material handling applications, the robots can be used for moving the objects or loading or unloading the objects. Material transfer, that means we can transfer the material from one place to another place, and the machine loading and unloading applications also can be done easily with the help of a robot, where we will attach a special type of attachment to the robot, which is called a gripper. A gripper is attached to the robot, where it can be used to hold the objects while moving from one place to another place. Now these grippers are there. Many types of grippers are there. We have already discussed in the previous lectures. There are like mechanical gripper, where it uses some mechanical fingers, and second one is magnetic gripper, where it uses electromagnet, where when electricity is supplied to the magnet, it will get magnetized. And then vacuum grippers are there, which will uses vacuum suction cups for holding the objects. And then hooks are there, where they can carry loads which are attached to the robotic hook. And then scoops are also there, where they can be used to carry molten metal in the scoop, which is attached to the robotic end effector. So these are some of the the grippers which are used for robots. So using these grippers, we can manipulate the object. We can actually carry the object. So each and every gripper has a particular purpose and particular application is there, depending on that object which we have to lift or which we have to move. We should use different kind of gripper, like mechanical, magnetic, vacuum, etc. So each type of gripper will have different load carrying capacity. So using these grippers, we can carry any object from one place to another place within the work envelope of the robot. Work envelope is the volume around the robot in which it can work. Now, material handling applications are those in which robots move materials or parts from one place to another place. To accomplish the transfer, the robot is equipped with a gripper type of end effector. So, we have seen what is a gripper and what are the different types of grippers are there. So, the gripper must be designed to handle the specific part or parts that are to be moved in the application. So, if I am using the robot to move a glass object, I have a glass plate, I should go for vacuum gripper, where the vacuum gripper has the suction cups where it can hold the glass surface by sucking on the surface by using a rubber made suction cups. So these suction cups are connected to vacuum compressor where the air inside the cups can be easily removed and it will hold the object for a as long as the suction is there, the object will be held within the suction cups. So when I am using glass objects, I cannot go for mechanical grippers because mechanical grippers uses some kind of mechanical fingers which are made up of metal or plastic sometimes, where they have to hold the object very tightly to lift it. So while holding the object very tightly with a mechanical finger, these mechanical fingers will apply some kind of force on the glass plate where it may break the glass plate eventually, which causes a damage to the product. We should not damage the product. We should carefully handle the objects, or we have to move the object from one place to another place very precisely without causing any damage to the objects. So this is the main motto of using a gripper or using a robot. So when I am going for, if I want to lift a metal part, so I can simply use any mechanical gripper or magnetic gripper. If the metal is of a ferrous element, I can simply use magnetic gripper because all ferrous elements are magnetic, and I can attach this magnetic gripper on the object and I can lift it and I can move it from one place to another place. So the load carrying capacity of the magnetic gripper also depends on its size of the magnet. Bigger the size, bigger the load carrying capacity. Mostly we will use electromagnets where electricity is passed to the magnet and it gets magnetized. When electricity is turned off, the magnetism will be lost. So this application of using electromagnets in robots was first developed in the year 1970s by the industry, which is an industry which is using these robots in automobile manufacturing. So where the robots can easily hold the body parts of the car and it can lift from one place to another place. So this is how when I'm using when I want to shift an object from one place to another place by using a mechanical gripper. When the object is made up of metal, I can use mechanical gripper or magnetic gripper. Okay, and if I want to shift an object which is made up of metal, and this metal has very smooth surface. When the object is very smooth, then what we have to do is we have to use a vacuum type of gripper, because when the surface is very smooth, the mechanical grippers may lose the object. I mean, they cannot have the proper friction on the object. That is why the object may be removed from the mechanical gripper. Or sometimes I have an object which is not magnetic at all. If I am using an aluminum body where I have to hold this object where there is no magnetic power in the metal, so then I should go for vacuum type of gripper. So this is how, depending on the different types of applications, we have to select a particular gripper, and this gripper is suitable only for the particular metal or particular object which is designed. So the design and the selection of the grippers must be done in a proper way. That means a particular object can be held by a particular gripper. If I have a cylindrical rod, it needs a special type of gripper which is in the shape of circular. If I am holding a rectangular object or a square, I mean a cube, I should need a mechanical finger which is designed in such a way to hold the cube. Okay. Now see here, the robots can be used for two different applications in material handling. Like they can be used for material transfer, where they can transfer the material from one place to another place by using the mechanical robots, and machine loading or unloading. While we are using a CNC machine, we have to load the workpiece into the machine, or we have to load the tool into the machine. So for doing this, there is no need for human every time. We can simply use a robot for loading the workpiece into the machine, where the object will be processed and it will be manufactured or machined in such a way as required by the end product. And this object, after the completion of the machining, the object has to be removed from the CNC machine, where it can be stored in the warehouse. So this process can be done by a robot. This comes under material loading or unloading. Then here we'll see how robots can be used for material handling or material transfer applications. So these applications are one in which the primary purpose of the robot is to pick and place at one location and place that at a new location. So in this picture, we can simply see the object is placing or stacking the objects in a cart. So these crates are made up of wooden. So the objects or the items which are placed by robots are very small, and these are made up of metal, and these are placed or aligned in a perfect manner, where they have to fill the entire box without losing any extra space, without requiring any extra space. They should be properly aligned in the box. So the fixed number of objects has to be filled inside the crate. See here, there are like some objects are being kept in the box. So these objects are aligned in one direction, whereas the other set of items here, these are all aligned in the opposite direction. So they are placed in such a way so that the box should be properly filled. So for doing this, I will write a small program for robot, and this robot will follow that instructions. Like whenever the first row is completed, it has to realign or reorient the objects in opposite direction, where it has to fill the other set. So this is first set and this is second set. Okay, both are placed in the crate in opposite directions. This orientation can be done by the robot itself. We don't need to go and reorient them. Robot is completely automated. It can automate the filling of the box, and also it will pack the box as required. So in many cases, reorientation of the part is accomplished during the relocation. Here reorientation is done. The robot will do the reorientation while keeping the items in the box. Only 2, 3 or 4 jointed robots are required for most of the material transfer applications. Now see in this picture, we have a robot which is made up of 1, 2, 3. 3 joints are there. I mean 3 links are there. Okay. How many links are there? Link 1, joint 1, joint 2 and joint 3. There are 3 joints which are making this robot mobile. So mostly 2, 3 or 4 jointed robots are used in material transfer, where they can be used to load the objects into the box. And now, pneumatically powered robots are often used for these applications. So we know pneumatic is cylinder piston arrangement is the one which can create linear motion. We will use a compressed air. When this compressed air is pushed into the cylinder, the piston inside the cylinder will move in or out. But the pneumatic cylinder arrangement will create a jerk motion. It does not move the piston slowly. It will immediately push the piston to other end of the cylinder. So when we require this kind of motions, we can use pneumatic cylinders. So mostly in this application, where the material is transferred from one place to another place, we can use pneumatic cylinders for moving the objects. While placing the objects, we can simply use pneumatic cylinder because it will release the object into the crate. Okay. So a more complex examples of material transfer is palletizing. Now this is one important thing where robots are being used for palletizing operation, where the robot will keep a number of boxes like this in this manner. This is also called as stacking. Stacking the box, one box on the other, this process is called palletizing. Now see here, after this process is completed, when in the first picture we are seeing the robot is used to fill the objects into the box. Now after the box is filled, this box has to be lifted, and this should be placed on a base frame, and where they are palletized. That means a large number of boxes are placed on one layer, and after them another layer of boxes are placed on them. So this is called palletizing, where the robots can be used for not only the filling of the objects, but also they can pack and palletize. They can pack the boxes and they can stack the boxes on another box. So this is called palletizing operation, where the robots do a very good work when compared to human beings. They can work precisely and they will require less time. And the second kind of a material handling application is machine loading or unloading. Sometimes in this picture we can see there is a CNC machine. This is a CNC machine where the robot, this is robot, the yellow colored part is called robot, and the robot is actually doing some operation. What it is doing, it is fixing the workpiece into the CNC machine. So when we are working for 2 to 3 operations, like I have 2 machines. One machine is CNC lathe machine, another machine is the CNC milling machine. Now I have to transfer the object from CNC lathe machine to CNC milling machine. For that purpose, I need a human being who can work for only 8 hours a day. If I want to automate this entire process, I can use a robot where it can load the object into the lathe machine first. After the process is completed, the manufacturing process or machining is completed, this robot will automatically remove the end product from the lathe machine, and it will take the object to the milling machine where further operations are done. So for doing this, if I use a human being, he has to work only 8 hours a day. If I want to produce 24 hours a day, I have to use 3 humans, where they will require more wage when compared to a robot. And this robot also will work precisely, and in less time it can do the work very precisely, and it may adjust or align as very similar to human being. Now I have a lathe machine and I have a milling machine where I have to transfer the object from milling machine to lathe machine. These 2 machines are very closely aligned and they are closely installed. The robot is installed very near to them. So the robot has to move from lathe machine to milling machine. So this movement, the work envelope should be within the range. The 2 machines, milling machine and lathe machine, should be in the range of a robotic work envelope, where it can easily move the object from one machine to another machine. Now this process is called machine loading or unloading operations, where the robots can be doing multiple type of operations while loading or unloading. There are 3 types. First one is machine loading, where the robot can be used to load the workpiece into the machine, and it does not care about unloading of the object. Okay, it is only used for loading of the workpiece into the machine, and unloading is done by some other means. A human or another robot can do the unloading operation. Where second kind is machine unloading, where the robots are used for unloading the objects only. Okay, the raw materials are fed into the machine without using a robot, and the robot is used to unload the finished parts. Okay, and then third type is machine loading and unloading. So in this type of robots, it can do the loading and unloading also. Even we can write the program of the robot in such a way where we can load the object from one machine and unload after the process is done. And this same object can be loaded into a second machine, and after that, it can be unloaded. So, multiple loading and unloading operations can be done by robots. So, these are some of the material handling applications. In this lecture, we have seen what are the different applications of robots in material handling and processing operations. They are working in hazardous environments, working in repetitive processes, working in there is no infrequent changeover. We don't need to change the equipment around the robot frequently, and repetitive cycles. So after that, we have seen material handling processes like machine loading or unloading. They are all comes under material handling operations. So in the next lecture, we'll see some more applications where the robots can be used for special operations like welding, spot welding, or continuous arc welding. So these are the operations that can be done by robot, and they can be intensively used for manufacturing of automobiles and manufacturing of machine parts. So that is why the applications of robots are increasing day by day, and we'll meet in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.